Okay, so our last section of 9.7, we are going to talk about law of sine and law of cosine, which is a little bit different from what we've been doing, because with law of sine and cosine, we don't have to have a right triangle. It helps us solve triangles that aren't right triangles. I like to do this section in honors geometry as a basic intro because it helps to give you guys a baseline for when you get into pre-calculus and calculus. You'll have that baseline of knowing what law of sine and law of cosines is. Okay, so we're going to start off nice and easy. We're just going to use our calculator to find the value of each of these trig functions in our calculator. So again, you want to just make sure that your calculator is in degree. And in your calculator, for number one, you're just going to hit tangent. You're going to type in 110 and hit enter. So when we round that to the nearest 4 decimal places, we're going to get negative 2.7475. And then we do the same thing for sine of 97 degrees. Rounding to the nearest 4th decimal place gives us 9925, 0.9925. And again with cosine of 165 degrees is going to give us negative 0.9659. So the reason that we do this is because in this section, when you're using law of sines and cosines, you're going to have angles that are not between 0 and 90 degrees. You're going to have obtuse angles that you're finding sine, cosine for, and you might end up with negative answers, and that's okay. So we're going to start out a little easier in this section first, and we're going to find the area of a triangle. So, most of the time when we find area of a triangle, we have to do 1/2 base times height. But if you don't know the height of your triangle or the base of your triangle, we can use the formula using trig functions. So it's just 1/2 times the 2 side lengths you have times the sine of your angle. Now, it's written 3 times because basically if we have side C and side B, then we have to have that angle in between them, which would be angle A. So as long as the angle that you have is in between your 2 sides, you can use this trig function equation to solve for the area. Don't forget to include your units when you're finding the area. So if it told you that the side lengths were in feet, then when you find your area, it would be in whatever that is, feet squared. So don't forget to add your units, whatever those may be. If it doesn't give you a specific unit, add a generic unit squared at the end. Okay, so in 4 and 5, we're just solving for the area. So in number 4, angle B is 60 degrees, side A is 19, and side C is 14. So the area is just 1/2 times your sides times the sine of your angle. So we're going to plug this into our calculator and round to the nearest tenth. If you need to do this in steps, that's fine. 1/2 times 19 times 14 is 133. And then we're just going to multiply that by the sine of 60 degrees, which is going to give us 100, not 155, 115.2 units squared. Now, if you do that all in one step in your calculator, 1/2 times 19 times 14 times sine of 60, that's fine. If you want to do it in multiple steps, that's also fine. So I'm going to have you go ahead and try number 5 on your own, pause the video, and then come back when you are ready to compare your answer. Okay, so 1/2 times our side of 38 times our other side of 31 times the sine of 29 degrees. So 1/2 times 38 times 31 is 589 times the sine of 29 gives us an area of 285.6 units squared. Okay, so in law of sines, we solve with law of sines just using ratios. So we have three ratios in the equation all set equal to each other, but you're only ever going to use two at a time. So you're never going to use all three at the same time. We're just using two, and it's a cross multiplying situation just like we did a few chapters ago. But you've got two different ways you can write it. You can write it with your angle in the numerator and your side in the denominator, or vice versa. Now, if you're solving for an angle, write it with your angle in the numerator. If you're solving for a side, you want your side in the numerator. It just makes it easier. It doesn't matter either way, which way you do it, but it does make it easier to solve if whatever you're solving for is in your numerator instead of your denominator. Okay, so either sine of A over A equals sine of B over B equals sine of C over C, or A over sine of A equals B over sine of B equals C over sine of C. So remember, it makes it easier to label triangles if whatever our angle letters are, we use the same for the sides. So if angle A is here, side A would be opposite. Side B would be opposite angle B, and side C would be opposite angle C. So that's just how they tend to label all of their triangles. Okay, so we're just going to solve the triangle. So it's the same thing as in the last section when you're solving the triangle. You're just solving for anything that we don't have. So we don't have angles B and C, and we also don't have side B in number 6. So what we know is that angle A is 51 degrees, and side A is 18, and side C is 17. So if you're given one angle, you want to solve for an angle first. So we know that the sine of A is 51, so sine of 51 over side A, which is 18. And then since we know side C, that's the angle we want to find first. So it's equal to the sine of angle C over 17. So this is just a matter essentially of cross multiplying and simplifying. The way I like to do it is I like to say, okay, the sine of 51 is 0.7771459615, so on. And then I like to divide that by 18. Don't round it before you divide, just leave it as is. So essentially we have 0, 4, 3, 1, 7, and so on is going to equal the sine of C over 17. Now, if you are writing these down in steps, it's okay to round on your paper, but in your calculator, make sure you use that whole answer so that it doesn't mess up a final answer. So to get sine of C by itself, we're going to multiply by 17. We're going to undo that division by multiplying both sides by 17, which is going to give us about 0.73397 equals the sine of angle C. Well, remember, to get C by itself, we've got to inverse that sign. So we're going to take the sine inverse of that decimal that we have to solve for C. So in your calculator, you should have that 0.73397118858, just second of sine to get our sine inverse. And then if you just hit second of that negative sign, it is going to put the answer from your step before into your calculator. And just hit enter. We're rounding to the nearest tenth. So for angle C, we're going to get about 47.2 degrees. So now to find angle B, we can make that a lot easier because all of those angles have to add to 180. So we can just do 180 minus the 51 for angle A minus the 47.2 for angle C. And we can get 81.8. So now when we're solving for our last variable, which is this side B, we can just set up a simpler ratio. So we're solving for a side, so we're going to put our side in the numerator. Now, just like in section 6 where I kept using the things that we were given, that's what I'm going to do here as well. So I'm going to use 18 over the sine of 51 equals side B over the sine of angle B, which we just found to be 81.8. So in my calculator, I'm going to do 18 divided by the sine of 51, which is 23.16167, so on. And then to get side B by itself, I'm just going to multiply by the sine of 81.8, which gives me 22.9 to the nearest tenth. So we're going to do the same thing in number 7, only I'm not going to take as much room to do that. You don't have to show as much work as I showed in number 6. You can do things like sine of 51 over 18 times 17 all at once, and then just do your inverse sine. That's not a big deal. I'm really just trying to show as much as I possibly can for you guys. So we know side B is 13, side A is 16, angle A is 40. So we need to find angles B and C and side C. So when we're given our two sides, we're going to start by finding an angle first. So we know that the sine of 40 degrees over 16 has to equal the sine of angle B over 13. So in my calculator, I'm doing the sine of 40 divided by 16, which gives me about 0.04017. And then I'm going to multiply that whole decimal by 13, which gives me about 52226. And then to get B by itself, I'm going to do the sine inverse of that decimal. So remember in your calculator, you want that whole decimal. So second sine, second negative, we'll put that whole decimal answer into that step for you. And then to the nearest tenth for angle B, we get about 31.5 degrees. And then I'm going to find that third angle next. So 180 minus 40 minus 31.5 is going to give me an angle of about 108.5. So now I have all three of my angles, and I just have to find my third side. So again, I'm going to use my given information, and since I'm finding a side length, instead of doing sine of 40 over 16, I'm going to do 16 over the sine of 40. Is going to equal that side C that I need over the sine of 108.5. So in my calculator, 16 divided by the sine of 40 is about 24.89158,123. And then to get C by itself, I'm going to multiply that by the sine of 108.5, which is going to give me my C value, the length of side C, to be about 23.6. Okay, so we're doing the same thing in 8 and 9. If you feel confident in it, go ahead and try it on your own. If not, just pay attention and we'll go through it together. So when you're given two angles, makes it much easier to find the third angle because you don't have to do any trig values for that. So we need to find angle A in number 8. So we can just go ahead and say 180 minus 107 minus 25 for those angles C and B. To get that angle A is 48 degrees. And then we just have to solve for sides A and C. So we know that side B is 15. So we're going to use side B and angle B to solve for A and C. So I'm going to do the side length over the angle. So 15 over the sine of 25. And I'm going to solve for side A first. Is going to equal A over the sine of what we just found angle A to be, which was 48 degrees. So 15 divided by the sine of 25 is going to give me about 35.493 and so on. And then I'm going to multiply that by the sine of 48, which is going to give me about 26.4. And I'm just going to do the same thing for side C. So I'm going to use sides B and angle B again. So 15 over the sine of 25 is going to be equal to side C over the sine of 107. So 15 divided by the sine of 25, again, is 35.493, so on. And then I'm going to multiply that by the sine of 107. And to the nearest tenth, that's going to give me about 33.9 for side C. Okay, so same thing for number 9. We are just solving for two sides in an angle. So we're given two angles, so I'm going to find angle E by doing 180 minus 97 for F minus 42 for D, which is going to give me an angle of 41 degrees. And then I'm just going to use that information to find all of my sides that I need. So I'm going to start with what I was given, which was side F and angle F. So 12 over the sine of 97 degrees is going to equal side D over the sine of angle D, which is 42. So in my calculator, 12 divided by the sine of 97, which is 12.0901179, so on. And then I'm going to multiply that by the sine of 42, which to the nearest tenth is going to end up giving me about 8.1. And then I'm going to do the same thing for side E. So I'm still going to use 12 and sine of 97. And I'm going to set that equal to side E over the sine of 41 degrees. So 12 divided by the sine of 97 gives me that 12.0901179, so on. And then I'm going to multiply that by the sine of 41, which is going to give me about 7.9 for side E. So you'll notice that D and E are very close together. D is 8.1, E is 7.9. But if you look at their angles, angle D is 42 and angle E is 41. So the closer the angles are together, the closer the side lengths will be together. The farther away that the angles are away from each other, like 42 and 97, is going to make the lengths of the sides a bigger difference. So like 12 and your 8.1. So don't panic if you get answers that are really close to each other, because that just means that their angles are very close to each other. They have similar angle measures. Okay, so a surveyor makes the measurements shown to determine the length of a bridge to be built across a small lake from the north picnic area to the south picnic area. Find the length of the bridge. So the north picnic area to the south picnic area goes from A to B. So we want to find that length C. Well, to do that, we know the length of side B is 150 meters, but we don't know that corresponding angle. We don't know angle B, but we do know the other two. So we can find angle B by doing 180 minus 71 minus 60. So if we do that, we find that angle B is 49 degrees. So now we can take that information and solve for side C with our law of sines. So side B is 150 over the sine of angle B, which is 49, is going to equal side C over the sine of angle C, which is 60 degrees. So 150 divided by the sine of 49 is going to give me about 198.7519, so on. And then I'm going to multiply that by the sine of 60. Which is going to give me about 172.1 meters. Make sure you add that unit of meters on there since it's a story problem and it's asking for a length. You don't have to find side A because we don't need to know the length from the south picnic area to the east picnic area, just the north to the south picnic areas. Okay, so law of cosine, I don't want to say it's harder. It can be a little bit trickier because the formulas are a little bit trickier. So the formulas that you see here are going to be for when you're finding side lengths. And if you notice, they're all squared, a squared, b squared, c squared. So you're going to have to take the square root to find the actual side length. So don't forget to do that. Now, if you're solving for an angle, so for example, the cosine of A would be b squared plus c squared minus a squared all over 2bc. The cosine of B would be a squared plus c squared minus b squared all over 2ac. And the cosine of C would be a squared plus b squared minus c squared over 2ab. So that's just a different set of formulas that you can use to solve for your angles. Now remember, it's cosine A, cosine B, cosine C. So to get A, B, and C by themselves, you'd have to do your inverse cosine. But that formula makes it a little bit easier to solve for an angle than the ones above. But either way, it'll work for an angle or a side as long as you're completely solving. So law of cosines. Let's look at a few examples. So when we look at number 11, we are given side A, side C, and angle B. So we need to find side B and angles A and C. Now the nice thing with law of cosine is usually you use law of cosine once, and then if you want to, you have enough information to go back to law of sine. But that's totally your decision. You can use law of cosine the entire time, or you can use a little bit of both. So the first thing that you want to do is you want to find your side B first. So B squared is going to equal A squared, which was 45, plus C squared, which was 43, minus 2 times A times C times the cosine of that angle B, which was 88. So it's just a matter of working that all out. So 45 squared plus 43 squared is going to give us 3874. And then 2 times 45 times 43 is 3870 times the cosine of 88 degrees. So you want to be careful when you're plugging this into your calculator. You don't want to mess up a step. I would get to this second step that I have before you try to put it all in at once. And then if you want to put this whole step all in at once, make sure you put that 3870 times cosine of 88 in parentheses. That way your calculator doesn't accidentally make a mistake. So we should end up with about, when we do 3874 minus 3870 times cosine of 88, you should end up with about 3738.9389, so on. But remember, that's equal to b squared. So in order to get b by itself, we've got to take a square root. So when we square root that number, we get about 61.1. So now we just have to solve for our two angles. Now I am going to continue with law of cosine just so that you can see it. So if I solve for angle A first, the cosine of angle A is going to be my b squared, which is 61.1, plus c squared, 43 squared, minus my a squared of 45 squared, over 2 times b times c, or 2 times 61.1 times 43. So when I plug this into my calculator, 61.1 squared plus 43 squared minus 45 squared, I get 3557.21. And then 2 times 61.1 times 43, 5254.6. Now to get angle A by itself, we got to do the inverse cosine. So what I would do in your calculator is just inverse cosine of that fraction, 3557.21 over 5254.6. That way you don't have to worry about making sure you have an entire decimal in there. When you do that inverse cosine, you get about 47.4 degrees. So all we have left to find now is angle C. Well, we know two of our angles, so if we find the third angle, we just do 180 minus 88 minus that 47.4, which is going to give us an angle measure of 44.6 degrees. So that is our first law of cosines. So if you feel confident to try number 12, it's the same situation, it's the same setup, just with different numbers. So we know angle A, we need to find side A, and we need to find side angles B and C. So I'm going to, if you feel confident, pause it and try it. If not, just follow along. So I'm going to find side A first. So A squared is going to equal B squared plus C squared, or 23 squared plus 26 squared, minus 2 times 23 times 26 times the cosine of angle A, which is 114 degrees. So 23 squared plus 26 squared is 1205. 2 times 23 times 26 is 1196 times the cosine of 114 degrees. So if you plug this in your calculator all at once, do 1205 minus parentheses 1196 times the cosine of 114. Make sure you close all your parentheses up. You should get about 1691.457, so on. But remember, that's A squared. So we have to take the square root of that whole thing. So to the nearest tenth, we end up getting about 41.1 for side A. And then we have to solve for our angles. So it doesn't matter if you solve for B or C first. That's totally your call. I like to do things alphabetically, so I'm going to solve for angle B first. So to solve for angle B, cosine of B is going to equal A squared, which we just found to be 41.1, plus C squared, which is 26, minus B squared, all over 2 times A times C. So 41.1 squared plus 26 squared minus 23 squared is going to give me 1836.21. 2 times 41.1 times 26 gives me 2137.2. And then remember, inverse cosine. So the inverse cosine of 1836.21 divided by 2137.2 to the nearest tenth is going to give me about 30.8 degrees. Make sure you're rounding completely. And then to find our last angle, 180 minus our 114 minus our 30.8 gives us about 35.2 for angle C. Okay, so when you have all three sides, which is the other type of law of cosines. So the first type was two sides with an angle in between, or side angle side. The second type for law of cosines is when you have all three sides. So a side situation. So we're just solving for angles. It does not make any difference which angle you start with. Again, I like to do alphabetical order. So I'm just going to start with cosine of angle A. So side A is 4, side B is 6, side C is 5. So cosine of A is going to equal B squared plus C squared minus A squared all over 2 times B times C. So 36 for 6 squared, 25 for 5 squared, minus 16 for 4 squared is going to give me 45. 2 times 6 times 5 is going to give me 60. So inverse cosine of 45 over 60 gives me angle A of 41.4 degrees. And then I'm just going to do that again for another angle. So if I do cosine of B, A squared plus C squared minus B squared over 2 times A times C. So 16 plus 25 minus 36 is going to give me 5 over 2 times 4 times 5, which is 40. So inverse cosine of 5 over 40 is going to give me an angle B of about 82.8 degrees. And now I've got two sides, so I can just subtract those from 180 to find angle C. So 180 minus 41.4 minus 82.8 is going to give me about 55.8 degrees for angle C. Okay, so that's how you're finding when you have all three sides. So that's how you find your angles. So I would really like it if you would try 14 on your own. Side A is 23, side B is 27, side C is 16. If you need to follow me, go ahead and just watch again. But really try to see what you can get through on your own. So if I start with angle A, 27 squared plus 16 squared minus 23 squared over 2 times 27 times 16. $456 over 864. When I do my inverse cosine of 456 over 864, I get an angle of about 58.1 degrees. Cosine B, 23 squared plus 16 squared minus 27 squared over 2 times 23 times 16 gives me $56 over 736, which gives me an angle of about 85.6 degrees. And then for angle C, 180 minus 58.1 minus 85.6 is 36.3 degrees. So our last one, in organisms, step angle is a measure of walking efficiency. The closer the step angle is to 180, the more efficiently they walk. The diagram shows a set of footprints for a dinosaur. Find the step angle B. So we need to find this angle. So that's going to be our angle formula. And this is the only one we have to do because it's the only angle we have to find. So 155 would be A, 197 would be C, 316 would be B. So 155 squared plus 197 squared minus 316 squared over 2 times 155 times 197. So when I add 155 squared and 197 squared, I get 62,834. And then I subtract 316 squared which is going to give me negative 37,022, which is completely normal to get a negative value when you're doing law of cosines. Don't panic. The bigger the angle, the smaller the number. So it can be just a smaller positive or it can be negative. That's okay. And then 2 times 155 times 197 is 61,070. So we're doing inverse cosine now to solve for that angle. So don't forget your negative, because if you do, it will give you the wrong answer. So inverse cosine of negative 37,022 divided by 61,070 is going to give you an angle of about 127.3 degrees. Okay, so if you have questions, let me know. This was a long section, I know that. So just let me know how you're feeling about it. If you need me, I'm around.